city local or if it's not there, then you can say.
Okay, so hey guys, so this would be the last talk. So I know it's getting late, so I will try to wrap this up in around 20 minutes. So introduce again, I'm Mark. I work at Wiki, and my day-to-day thing is Go related. Okay, so so today I'm gonna talk about the garbage collector. So how many of you know what Go garbage collector is and have like tinkering something with it? Yeah. Okay. So I hope this is like short introduction to maybe to look into it in the future if you run into problems. So what to expect from the talk would be at first I will go about some historical information like how memory allocation was done in C, and then we'll look at how it's done in Go. So on this is the reason why we need the garbage collector in Go, and then we'll see it in action, and well, they will see some consequences of the garbage collector. So do it fast. So history, if you come from a C or C++ background, then you used to have to allocate and deallocate memory manually. And then if you do that, you would remember that there's two things, the stack and the heap, right? If you call a function and then you declare, like for example, this program is just simple finding the max of two number. Right, and in C, if you declare something in the function and then don't use it, then it will basically live on the stack. Stack is just a space in the virtual memory where you allocate this function, this variable, and then when you exit this function max, which means you are you come to here, and then it exits the function. The space for that. The stack space for that function will be deallocated. So in effect, this is why in C you cannot access variable in another function. So it's like local variable, right? But I can write this in another way. Is that instead of returning the value, I return the pointer to another address space, right? So like for example, this one in the max function, I allocate some space. So this go on to a different space called the heap, and then I assign the value of the larger number to it. So it goes here, and then when I exit the function, the stack for the max function is deallocated, but I still have the address of some memory space with the value of the larger number. So in effect, this is how C used to deal with like local variable and then share variable. So anything that's shared goes to the heap, and then anything that's local go to the stack. And then you would, if you notice here at the end, I would have to do a free on the memory that I allocated. So anything goes to heap will stay there until you deallocate them. So that's C. Then let's go back to Go. So now in Go, the code to do the max function sort of look the same. So I have a result here, and then I assign the value to it, right? So can any of you guys guess, like, will this be on the stack or the heap? How many stack? One. You guys, the rest?
Stack is not. Yeah, what? Yeah.
Okay. Yeah. So this. Yeah, so it kind of go to some space that is similar to the stack in C, right? But in Go, actually, there's no concept about stack or heap, but it knows which variable goes where. So I'll elaborate it in a bit more. So then, okay, so now I have this function, this program. So this is simply, I have a Gopher struct. I take a function, I have a function that takes in two Gopher struct pointer, and then produce a new Gopher struct pointer. Okay, and if you look at it, it's interesting because in this read function, right, I take two, I produce a Go struct, and then I return the address of it, and then I can use that information outside. So if you remember the example with C back then, right? If I declare something in the function, it will be local. It will be in the stack, and nobody outside can access it, right? So how come I can get this value here and display? So this is essentially like the quirk and the benefit of Go is that it knows when your return address or your variable, like whether it's going to be shared among other Go routine or not, and it allocates that information to the stack and the heap accordingly. And if you notice, at this point, I don't have to do any memory deallocation at all, right? So where does that variable goes? Like, I mean, it occupies some memory, right? So what happened to that? So that brings us to the garbage collector. So the point of the garbage collector is to look for these like unused, unallocated space that nobody care about, and it will deallocate them. Okay, so I'll do a very quick like example to see how it works. So anyone, are you guys following so far? Like any question? Okay, so that's the ugly code. Okay, so okay, so what I have here is a very simple HTTP server. Alright, so it listens and serves on 9099, 90, and then what it does is it returns a JSON, which is marshaled from a Gophers struct. And if you look at it, this is the same as the second Go example I gave, where I allocate some struct inside the function, return the address, and don't do anything. So what will happen now is that I'm gonna compile this thing, and then I will run it without the GC. Okay, so now it's running. So let's. Oh, okay.
What's going on?
Okay. So I mean, to know what does the GC do, just turn it off and then you see the effect like immediately. So okay, so. Okay, so okay, so what I'm printing here is what I'm printing here is the memory usage of this server. So RSS means total memory usage in RAM, and then VSZ is virtual memory, right? So you see that the virtual is a bit more because I don't know what account for that. But okay, so now what I will do.
How much is that? Is that 3,000?
All of this is in byte.
So 3 megabytes.
It's in bytes?
If I'm not wrong.
Megabytes,
Oh, it's 1,000, right? Yeah, it's 1,000, so it's kilobyte, yeah. 3 kilobytes something. So, oh, sorry.
So
What?
3 meg, 7 meg, so
Yes.
8 meg.
Right.
So what I'm doing now is I'm gonna run a benchmark tool, which basically bombard this server with a lot of requests, right? And then you see right away what happened without the GC. So now you notice that the memory usage of the server increased like a lot.
It's not that much considering nothing's being free. Or why isn't it going up linearly or whatever?
It doesn't go up anymore.
Why is that?
Oh, sorry, I run it wrongly. Sorry. So stop.
So now we saw
When it's working.
yeah.
Okay, so
Yeah.
basically this is when it's working. It only so let me run it again with the
Is WRK your own tool or is that part of
GC off.
WRK is some if you use like AB the benchmarking tool
Yeah.
for Apache before it's
Yeah,
similar. There's
is it
another
your own
guy.
tool or is it a open
Um,
source tool?
Yeah, it's another guy project.
Oh.
Okay, So I'll run it again with the GC off.
What did you? Oh, GOC.
GeoGC.
GC off. Okay.
Okay.
And let's find the process again.
You need to do a P grab.
Yeah, I like this better. Okay. And then bombard it.
Okay, 40, 80,
So now it
100.
explodes, right? And it will keep coming and it will crash my computer, so I'll stop. But if you,
You can put that in a system D and limit the memory.
Yeah.
And then restart always.
so now,
System D start.
okay, so now I'm gonna look at the memory profile of the server within this span of time. So let me. pprof is a benchmarking utility.
Go to.
So this,
So it can actually tell you exactly where the memory is.
Yeah.
Whoa.
so right now without the GC is, and a few seconds running the benchmark, it's already eating 200 something megabyte. If I let it run like fully, it will be around 800 megabyte, and you don't want a server to consume this much memory, right? So then what happened when we run it with the GC?
Well, why is it the memory being stuck in that strange function read line or something? Isn't it? Shouldn't it be stuck in the Gopher?
No, because it's decoding encoding it with JSON.
I thought the memory is getting stuck in the Gopher struct or whatever.
This one is very small.
But it's not being free.
Right. So I'll just bombard it again. I'll get to your point like later. So we'll see what is actually being leaked and causing this memory bump. So
Yeah, that's
now
right.
looks much better, right? And then
It's not perfect though, considering.
Yeah, and then it will take a long time before it goes back down.
Yeah.
yeah. So I'll look at the memory profile again. And
Web.
okay, so this time it's only using around 2 megabyte. Right. So that's this is very good. Consider that it without the GC, it's taking like 40 times the amount, right? So the GC makes a very big difference. So what difference does it make here? So we go back to the program, and now I would compile it with GC flags. So this will basically run the compiler and showing all the information that it detects about memory. And then if you notice, there's a part here, right? So there was a pointer to a struct that escaped to heap. And if you remember about C, if it stay in heap, it will stay forever until somebody free it. So this is the guy that is actually leaking from our example. And without the GC, anything that you leak in your memory, stay there. Right? So that's what the GC is meant to solve, and it solves a lot of pain problem because if you remember back to the C day, like deallocating memory and correctly is a pain.
Can I go back to see the code for that line?
That's not
Certainly line code.
This one, the server.
Yeah. The code. I would like to look.
That means it's.
Yeah, sure.
Oh,
So I ran it with minus GC flag.
No, I mean the Meetup Go, the code, where you escape the heap.
Oh, okay.
Yeah, I see.
Okay. So sorry, no highlighting.
the return.
So here, right? So I allocate some struct, and then I return the address outside. So I mean, similar to C, this would be a memory leak, but because of Go have a GC, it don't leak out so much, right? So,
Why doesn't it tell you that in the SVG?
or it's just a way for it to display information, the benchmarking too. I don't deal with that.
So the dash M sounds a lot better.
Yeah.
But if you didn't know about it, then you're screwed.
When you run a very big production server, you don't know all the nook and crank.
Yeah.
Right, so they're looking at-
Well, it's good that you told me about that. I just wish that Prof could tell you that.
Yeah. Well, okay. So why should you, as a programmer, care about the GC? So one thing it's making your life much better, and by right it should just stay there silently without you knowing. But actually, when you run a highly performance system, the effect of the GC is real, and it can be painful for you if you don't know about it. So, for example, if you run a HTTP server, at this point, Go 1.4 has a stop the work, mark and script GC, which means when it tries to GC, it will stop everything, no response handling for you, right? And what that means is during that time, any client connecting to that server will be staff of request. And okay, so like we have a similar problem in Wiki at some time ago. We was looking at the timeout graph for our API client, right? And then we started to notice that periodically there would be a spike in timeout. It go down, it go up very periodically, right? So we tried to invest and we found out, oh, actually we are being GC because we put too much stuff in memory that at some point it will start GC and the GC takes too long. So this would be, the interval would be around 1-2 seconds. And that was not a good experience for any of our clients, right? So that's one. Now, if you think about a more critical system, say you are writing a system to transfer money, this could become a potential big problem. So like in this use case, I would have two service A and B talking to each other. So A send a money transfer request to B, and then the protocol may be stating that like as long as B acknowledged, then the money the transfer was successful, and then don't do anything else. Otherwise, retry. And then if B say is in Go or some Java thing, could be also a Ruby or Python, whatever, anything with GC, and it get GC at that point. And if the GC is a stop the work, then B will not be able to respond to A at all. At the same time, if you implement like timeout on A, saying that if the B guy doesn't respond to you after some time, then retry. You could run into this situation where B came back from GC, ran the transaction, send the acknowledge back, but that happened before this guy sent another transfer request, and without any proper checksum, then somebody get double the money that they're supposed to get. That's good for them, but you are in trouble. Right. So I mean, there's a lot of if in this scenario, but just think about it in terms of backend. Like, is there any service that you are writing and with a client who implement a timeout? So you could cause trouble for them if you don't respond timely, right? So this is some extra stuff. Like if you want to fix this problem, you have to understand your GC, and doing that is meaning of looking at like your memory performance and tuning it with certain things. Like maybe you want to GC very early, so you can set Go GC to some X number, which is a percentage, so of your total memory space, for example. So if it reach around that number, it will start to GC. So the time you spend on GC is much shorter. You can turn it off entirely if you don't want it, but this means you have to write very C-like code, and that's hard. And then you can change it on the fly. And then there's other tools like what I just used to benchmark and look at the memory performance. So yeah, with that, I hope I'm not running out of time. So I would like to end the talk. So I'm open to question.
You mentioned the pre-1.4 behavior. Sorry, I didn't. So what's the behavior? What's the current version? 1.5 or 1.4?
1.4.
Still stop.
Still stops. Yeah, the 1.5 version.
Right. So they are planning so that in 1.5 the GC run concurrently, which means that it doesn't stop anything. It might cause some slight overhead, but not as serious of stopping anything else.
For most application, the stop the whole thing is like very few milliseconds. It doesn't really affect much. But if you have like 60 frames per second, you need to do something. Yes.
Yeah, right.
So, how does DC know which part of memory is going to be?
Right. So
Lock and sweep, right?
right. So which part of the memory is local and which part should go to the heap, right? That's your question.
Part should be swept away. So in Java or any other languages, right, there's a reference counter.
Oh,
If
okay.
reference goes to 0, then it should be swept away.
Uh,
But in Go, there's no such thing.
um,
Yeah, how do you free memory?
I think it goes and look at. Right, I forgot the actual implementation of it. I mean, if you go and look at the internal GC code, then they will have a detailed implementation. I forgot how they actually do it because mostly I just look at it and yeah, but I don't think they do reference counting. Yeah. Then yeah.
How big were your processors which cost like 1-2 seconds calculation action?
Oh, so we was trying to do a in-memory cache ourselves. So we have a map, and then we just dump like this request map to this response, and then we have a lot of requests without any proper like canonization. So it could easily. I think we were storing like 10 gig of stuff in the memory.
Wow.
That was a bad implementation. That we fixed it, but
So what you're doing, each request you were storing it, and then giving you
right. So we cache it, right. So if the next request coming with the same URL, then we
Oh.
return it. The cache
so
response.
it's just
we-
like a very simple cache.
yeah. So we was trying that for some time, but it ran into this only small problem. Yeah.
So how did we solve that?
So allocate less memory. We canonize the URL. So now, like say, if your request come with a query, so you could have a lot of different query, but maybe most of them, it depends on your scheme, but maybe most of them result to the same response. Then I canonize them, and then I just return that. So I have less space in my map. Yeah. For example, that's an example.
Don't people like drop in varnish for that sort of use case?
Yeah.
Do you use
Well,
varnish or
some-
do you use that GoLang stuff?
We still have some part of it in Go. We have a varnish. Yeah, we can tell more about that.
What do I didn't get?
Varnish and API proxy GC thing.
Uh-huh. What's the exact question?
How did we solve it eventually?
The
Go
GC
GC.
on API proxy?
Yeah.
The issue of the stop the world GC?
Yeah.
So what we've been doing is we actually run GC every 60 seconds. So we never let our GC reach a point where it has to throw out a huge number of objects. I've actually brought it down to probably 600 seconds on 60 seconds for GC. But every 10 minutes I have GC running, and because we never really have huge number of objects per year. Our stop the world time is very small. It's nothing times out within that period. So we just run GC very frequently to ensure we don't have huge stop the world times. I think with the latest Go version, it became much better.
And the next one is gonna be concurrent also.
Yeah, so it used to still be a problem with the previous version. The latest version has become better. It's just running. We're just running it every 10 minutes, and I reach up to like I have 40 to 50 GB of data in my process, but my GC manages to run under 200 to 300 milliseconds. So even if once in a while, every 10 minutes, if there's a very small time period for which 200 to 300 milliseconds of GC.
So
200 milliseconds is a lot.
It can be, but it's much better than. So it used to grow to like 1 second, 2 seconds, 3 seconds. So and rather than taking a 3-second hit every hour, I rather take a 200 millisecond hit every 10 minutes.
yeah.
So
Is it possible to go to write programs which when I start without the GC, don't leave any memory and it's predictable? Like for example, I want to write the software which controls my quadriculture or something.
Right. You don't want a GC and then you
Yeah,
want
I
to
don't want
manually.
GC to be and all that.
I
Possible. Possible. You would have to pre-allocate your memory. So you will have to have global objects. And then, I mean, okay, if I, for a moment I take out go back to the C model, right? That's how you do with C program, where you don't do any runtime allocation at all. Is you have your memory allocated in space and you have your objects allocated.
So basically,
And
global objects and one main loop and that's it.
Correct, that's it. You never allocate or pre-allocate. You never allocate and deallocate on of that. But you will have to estimate your max object that you can handle in advance, and that's your limit.
In case in small software like what I think that's a quite nice workaround.
Yeah. No, it's practically used in like in embedded systems. It's used all the time. So embedded systems, that's the way the model. Nobody will allocate on your plan. Nobody will. You estimate your limits. You allocate memory. Right? You map your object to that memory. So it's pre-warmed when your program starts up, and then it's just from a pool you keep using no allocation. That's you could technically do that. It's we probably not investigated at the end.
So any more
Just
questions?
curious, are your processors still about like 10 gigs and your GC just run calculations?
So we don't allocate too many objects. What are most of our data is like cached in memory cache, and it is being actively used. So we don't. Well, I'll be honest. I've not done too much analysis because I'm getting the performance that I need. My suspicion there is I don't have too much deallocation happening. Too many pointers that need to be deallocated from the GC's perspective. Okay, all these objects have a reference and therefore I'm not going to bother looking at them. And GC is probably just handling small number of objects to be removed from cache.
Yes, I know for like V8, right? So as long as even you have like a 1 gig of memory, it starts to slow down because V8 kind of like try to move your memory a bit.
Getting the performance I need to not look further into it.
What is the reason for putting memory into processing?
So we have
Using Redis one.
no, we have a Redis level cache and then we have in-memory cache on top of it. So in-memory is like you get sub-millisecond response time. Which in-memory is like a request is there in cache is given. It's like on the stat sheet literally shows up at 0.00 sub-millisecond. Whereas with Redis it will start going into single digit, double digit milliseconds. So I can always kill my in-memory cache, not a problem. I can clean it up.
Any more questions? Okay, so if that, then I would like to close the meetup. Thanks for coming. I guess it's late, but if you want to know more, then it's Ampiran. I'm leading the platform team, and with me, and then there's some guys at the back.
Cool, thanks.